Hello, good morning students. In the previous video we studied about acceleration and we revised the chapter with a few points, okay, and we also studied an important point, that is uniform acceleration and non-uniform acceleration. If the object is in uniform motion, then its acceleration is zero. Always remember that, because if the object is in uniform motion, okay, if the object is in uniform motion, at that time its velocity is not changing, because the condition of uniform motion is that its velocity remains constant, and if its velocity remains constant, that means its velocity is neither increasing or decreasing. Okay, that means its acceleration or deceleration is by default is 0. Okay, so no need to go in determining whether its acceleration is uniform or non-uniform. If the object is in uniform motion, then its acceleration is 0. Forget about uniform or non-uniform. A simple example for you. So if the object is moving with uniform motion, then its velocity is also uniform. That means at point A its velocity is suppose 20 meters per second, and at point B also, let's say its velocity is 20 meters per second. Forget the time. So according to the formula of acceleration, we have v minus u upon t, that is 20 minus 20 upon t. In this case, its initial and final velocities are equal because it is in uniform motion, and that is why 0 upon t becomes 0. Hence, if the object is in uniform motion, its acceleration is 0. Okay? Moving forward, we start a new topic, that is graphs, describing motion with different types of graphs. We are going to study two types of graph, that is distance or displacement time graph, distance or displacement time graph, distance time graph, and second one is velocity time graph, distance or displacement time graph, and second one is velocity time graph. Okay, first we are going to focus on distance time graph. Okay, starting with distance time graph, we can describe the type of motion the object is in, whether it is in uniform motion or non-uniform motion. Okay, so we take the example of an object in uniform motion. A simple example, an object moving from point A to B. I have told you the example for uniform motion. We take equal intervals of time. Okay, we are taking equal intervals of time. In this case, I am taking 10 seconds, 20, 30, 40 and 50. Okay, and starting from 0 meters, it is covering 20 meters, 40 meters, 60, 80, 100. So these are the this is the distance covered, and that is the time taken. As you can see, it is having equal intervals. Okay, over here it is 10 seconds, 10 seconds and 10 seconds, and as for the motion, it is covering equal distances. That means 0 to 20, 20 meters, 20 to 40, again 20 meters, 40 to 60, 20 meters. So distance is 20 meters each interval. Okay, that means object is in uniform motion. This object is in uniform motion. Now we describe it on a graph. So we draw a simple graph on a graph paper, of course. Okay, and we take divisions. In this case, these are simple 10, 20, so I am taking 20, 30, 40 and 50. Over here we mark the distance: 10 meters, 20 meters, 30 meters, 40, 50, 60. We can go further, but for the explanation purpose, this much is enough. As you can see, now we have to plot the graph. So for 10 seconds, the distance covered is 20. So on y-axis we have distance, and on x-axis we have time in seconds, and this is time, distance in meters. Okay, so 10, it is covering 20 meters. So this is how you plot a graph. We already know that. At 20 seconds, it is covering 40 meters. So over here, we take 20 seconds at 40 meters. At 30 seconds, it is taking 60 meters. From this simple point you can see, if I go further, it will be a point in which it is a straight line. So if the object is in motion, then distance time graph is a straight line. Okay, if the object is in uniform motion, then distance time graph is a straight line. Remember this statement: if the object is in uniform motion, then its distance time graph is a straight line like this. Now for different cases or different scenarios, it will be a different line, but if it is in uniform motion, it is always going to be a straight line. It doesn't matter. A graph can be like this as well, and still it is uniform motion. It can be like this, and still it is uniform motion. As long as it is a straight line, it is in uniform motion. It doesn't matter. Okay, so if the object is in uniform motion, it will always be a straight line for equal intervals of time, like this one. Okay, similarly, if the object is in non-uniform motion, then we draw a graph for that as well, so that we can get the idea of what is happening. Okay, we mark different intervals. Then we take the object which is in non-uniform motion from point A to point B, 10, 20, 30, 40 and 50. At first it is covering 20 meters just like before, but after 20 seconds it is covering 25 meters. At 30 seconds it is covering 35 meters. At 40, let's say 50, and at 50 we can say let's 60. Okay, now we plot the graph for this. So at 10 seconds it is covering 20 meters, so one point is over here like this. At 20 seconds only 25, so somewhere between 20 and 30 we plot a graph like this, a point like this. At 30 seconds it is 35, so at 30, once again between 30 and 40 we get somewhere over here like this. At 40 seconds it is 50, so at 40 seconds it jumps directly to 50, and at 50 it goes to 60 like this over here. When I plot this graph, you will see that it is not a straight line. Okay, if the graph which is plotted is not a straight line, then the object is in non-uniform motion. Distance time graph. Okay, so if we plot a distance time graph and it is not a straight line, then it is in non-uniform motion, just exact opposite of uniform motion. If distance time graph is not a straight line, then object is in non-uniform motion. Non-uniform motion. Okay, so if we plot a graph of an object in motion and its graph is not a straight line, then simply the object is in non-uniform motion. I hope it is clear to you, students. Now we take the example of acceleration, not uniform and non-uniform acceleration, just acceleration. Because remember, from this graph we can only determine acceleration, but we cannot determine whether the object is in uniform or non-uniform acceleration. We'll get to that if I explain to you in a brief moment. You will understand it. Okay students, so I calculated a few values for you so it will be easier for you to understand. I have given a distance covered by an object for a few intervals of time, that is 10, 20, 30, 40 and 50, once again equal intervals of time. But this time we know that if the object is in acceleration, its velocity is not going to remain constant. Its velocity is going to change. That is why we have the distance covered by an object over here at random. It is not uniform. The object is not going to cover equal distances. But we want to check whether the object is in acceleration or not. So its velocity must be increasing. Okay, if its velocity increases, then the object is in uniform motion. So we check at first point, that is distance upon time. If we take this distance and time, so speed is equal to 20 distance time 10, so it becomes 2 meters per second. I taught you before. In the same way over here, 60 upon 20, so 2 3s are 6, so the answer is 3 meters per second. So obviously its velocity has increased, right? Okay, so in the same way we know now that its velocity is increasing, 3 4s are 12 and so on, its velocity is going to increase. Now we plot the graph of it so as to understand how the graph of an object in uniform motion will look like. Over here obviously the values are going up to 200 meters, so I will be plotting the graph in that manner. I take over here 20 meters, 40, 60, 80, 100, 120, 140. Okay, and time over here in equal intervals, 10, 20, 30, 40 and 50. So for the first 10 meters it is covering 20 meters, so first point will be here. At 20 meters it is covering 60 meters, sorry, at 20 seconds 60 meters, at 30 seconds 120 meters, and at 40 seconds somewhere over here at 20 200 meters, so right over here. So if I check the graph, it is going to be a curve like this. So the graph of an object in uniform motion is always a graph of an object in acceleration is always a curve like this. So this graph, if it is a curve, then it indicates acceleration. Now remember what I said about acceleration. Over here also the line is not straight, it is a curve. Okay, this graph is a curve. So if the line is curved like this, then it is still not a straight line. Hence this acceleration is not in uniform motion. Remember that acceleration is always non-uniform motion. The object is in uniform motion only if it is a straight line. Okay, I hope you got that. Now suppose I have a graph over here. And the object moved to a certain point, and then the graph is like this, 10, 20, 30. Graph is like this, a straight line parallel. That means after this it is not moving either upwards or towards below the line. It is at 30 meters. The distance is at 30 meters and time after 10 seconds. The object is not moving from 30 meters either to 40 or coming back to 20. This graph simply indicates that the object is in rest position. So from point at 10 seconds, the object has not moved to 31 or 32 meters or to 28 or 29 meters. That means it has remained at 30 meters even though the time has passed. That means starting from 0 over here, the object has moved from point A to a certain point at 30 meters away from point A. So this is the point A. It moved to a certain point B, let's say 30 meters away, like this, in 10 seconds. So the object has moved from point A to point B at a distance of 30 meters from its original point. in 10 seconds, but after that the time is 11, 12, 30, 20 seconds, then 30 seconds, but still the object is not moving further. That means the object is at rest position. So if the object is a straight line parallel to the x-axis, then the object is in rest position. Now I will give you a short diagram for all the things we have studied. Okay, so if the object is in uniform motion, it is a straight line. Okay, and if the object is in non-uniform motion, it is a zigzag line, not straight line. If the object is in acceleration, no uniform, no non-uniform, just acceleration, then it is a curve like this. And if the object is at rest, then it is like this, it is not moving. Okay, this is the in short what we have studied today. Remember these graphs. If you plot a graph for a given question, and if the graph looks similar to any of this, then remember this: if it is a straight line, it is uniform motion. If it is a zigzag line like this, then it is non-uniform motion. If it is a curve, then acceleration. And if it is a straight line parallel to x-axis, then it is at rest. The object is not moving. The object is not moving. Okay, students, pause the video and check out all the points that I have taught you today. Have a good day.